Okay, it's important to be able to find the domain of a function. Remember, your domain are your x values. What can you feed in to this function, this rule, without getting a bad answer, okay? There are two times you've got to be really careful when you're looking for your domain. If you've got a fraction, because you cannot ever have 0 in the denominator. So like right here, I see fractions, so already, you know, little bells should be going off in your head that, oh, I gotta be careful because I can't have 0 in the denominator. Okay, and the other time is if you have a radical, like a square root sign, because you can't have negative values under there. You can have 0, but you can't have negatives under here. So I've got to be careful on these two as well. And so let's just do this real quick. Who cares about the numerator? I don't care what's going on up there. All I care about is here. And hopefully you can see right here that x can't be 9, because if x is 9, 9 minus 9, I'm going to get 0 in the denominator. So first of all, I'm going to write this. X can't be 9. But you have to be able to write this in interval notation. So basically the way you're going to do that is going to be negative infinity to 9, and then 9 to infinity. This is the way it's written in interval notation. These parentheses say it's including everything up to 9, but not 9. So right here, I could 8.9999999 would work, just not 9. So this is the way you have to write it in interval notation. Same thing here. This one may be a little hard for you to just do as quickly, but basically go ahead and set it equal to 0. If you can't see it right off, solve for x. I'm moving my 7 to the other side, divide both sides by 2, so I can see x is 7/2. But here's the problem. If I plug in 7/2, I'm going to get 0. Can't have 0. So x can't be 7/2. So my domain in interval notation would be negative infinity to 7/2 union 7/2 to infinity. So that would be that answer. Fraction. Again, I don't care about the numerator at all when I'm looking for the domain. All I care about is the denominator. You need to set this equal to 0. There's two ways you can do this one. You can either factor it. I love to factor. This is the difference of squares right there, so you could write it like this. Then I can quickly see that x can't be negative 6, because negative 6 plus 6 is 0, and it also can't be a positive 6. All right, you could also set this equal to 0, move your 36 to the other side, take the square root of both sides. Just make sure you realize that there are two answers that x can't be. Now, when you write this one in interval notation, it's ugly, all right? It's still going to be negative infinity to negative 6, and then I've got a problem at negative 6. And then I can pick up right after negative 6, and life is good until I get to positive 6. Then I've got another problem, union, and then life is good again once I get past 6. So it's going to look just like that. So your domain is ugly, okay? So I like this answer, you know, but it always makes you leave it in interval notation on your ALEKS program. All right, now this one's a little tricky. I've got a fraction here, and I'm like, what would make this 0? Actually, nothing is going to make this 0. You know, you can put 0 in here, and you're going to end up with 2. You could put negative values in here, but when you square them, they're going to end up positive, and so then it's just going to be 2 bigger. There's nothing here that would ever make this denominator 0. It's almost like they're trying to trick you or something. So your domain is all real numbers. In interval notation, you're just going to write it like this. Everything works. Okay. Red light needs to go off. I don't have a fraction, but I have a radical, a square root. Anytime this is even, like even if I was finding the 4th root, the 6th root, the 8th root, you can't have negatives under there. Now you could if it was the cube root, okay? This is simply the square root. So what you want to do is whatever's under there, I know it has to be greater than or equal to 0. You can't equal 0 in this case. Solve that, and I can see that this is my domain, but I need to write that in interval notation. So it's going to look like this. This is a bracket. It's telling me I can use negative 8, okay, and then anything bigger to positive infinity. It's really important that you have the bracket and the parenthesis. They mean different things. You're never going to get to infinity, so that's why this is an open parenthesis right there. Okay, same thing right here. Again, I have a square root symbol. I know whatever's under here. So whatever's under there, I'm going to set that greater than or equal to 0 and then just simply solve. Now, I'm going to, since this one has a negative, you know, probably I would move this to the other side, but most people they like their variable, their x on the left. Okay, so be careful with your negatives. If I take this positive 3 and I move him to the other side, here's what I've got. And yes, there's more than one way to solve this. Then I'm going to divide both sides by a negative 4. Hopefully you remember on inequalities that when you divide by a negative, you have got to flip that inequality sign. So you actually end up with that. My domain is saying, hey, I can use 3/4 and anything less than 3/4. So it's going to look like this. Negative infinity to 3/4 bracket. Again, because it can equal 3/4. So that's what that one would look like right there. You do need to put them in this order. I've seen many times people will write it like this. Okay, it is kind of saying the same thing, but we're used to seeing the smaller value to the left. Okay, and so Alex would count that wrong. I'd probably take off a little half point for that. So make sure it looks just like that. All right, now let me do 2 more real quick. Number 20 and 21. Can you erase this? What about this one? And notice in all these, I've been using all these different letters to represent different functions. Again, that's okay. It all means the same thing. We just get bored of using an F all the time, I think, is the deal. Okay, notice here, there's no fraction. There's no square root. I really don't have to worry about anything. I can feed in anything into this function and I'm going to be okay. So again, here your domain is everything goes, all real numbers. And in interval notation, looks just like that. All right, 21, this is one of their favorites to put on the final. So let's look at this one. One like this, I should say, because they love it. Notice they have both problems here. They have a fraction and they have a radical here. So you've got to think about both things. This is the easiest thing. We've got a fraction, x can't be 2. Okay, otherwise I'd get 0 on the denominator. Then I have a radical, and this guy right here, I know he can only be greater than or equal to 0. So I'm going to solve him separately. So here I can see x is going to have to be greater or equal to negative 3. So I've got these 2 scenarios I've got to think about. So you can either, well, let's just start here. My smallest value is negative 3. So if I was just going to think about this for a minute, it's going to look like this. That's what it would look like. Okay? But I've got a problem because I can't forget, in the meantime, x can't be 2. So here's what I'm going to do. Things are good at negative 3 and beyond. So until I get to 2. So I'm like, ooh, at 2 I've got troubles. Can't use 2. So I've got a parenthesis. Union, and then life's good again right after 2. 2 just caused me a little grief right there. So it's going to look just like that. So again, this is one of their favorite ones. So be careful on that one. And that's it.